Next, I want to talk about how we can use dictionaries in order to use DITC function, the dict function. We talked about this briefly before. We said it's useful in order to create a list, right? So we said, for instance, if we say dt is equal to dict, it will create an empty list. But there's also additional things you can do with this dict function. First is you can assign values. Basically, you can pass a pair of key values as arguments in our dictionary. Let's say if I am creating a dictionary, I can just call this dt is equal to and I can just have a pair of values. The way you do it is that you can have strings. You don't need to put any quotations, and instead of column we assign them. So we say assign value 1 to key A, assign value, let's say 2 to key B. Now if I'm printing dt, we'll see that we have a dictionary and we have these values assigned. And this is good, especially if the type between dictionaries and between values and keys are different. But if we have been assigning, let's say, values that are both integer, we might receive an error because Python starts to do a little more comparison. Again, we mentioned that Python is kind of smart in terms of reading the type of values that we're doing. So in this case, it thinks that we are trying to compare source values and is asking us if we mean equal or double equal sign. So that's something to keep in mind. So if I was doing A and B or any other string, it would work, but in some cases it might not work the way we want it. Another way to assign values into a dictionary using dict function is when we have a two-dimensional list. A two-dimensional list, as an example, so we have a list. Let's say we have a list. Typically our list would have 3 values within brackets. Let's say I have Monday, Tuesday, and Wednesday. So this is an example of a one-dimensional list. A two-dimensional list is when we have a set of paired values within our list. So let's say we have, if I want to show this better, we can think of this as a set of paired values that are stored in a variable as a list. So if I'm checking the type of this is still a list, but now if I have variables that are set in 2 dimensions and only in 2 dimensions, now I can use dict, let's say B is equal to dictionary A, and if I'm printing B, I see that now that has defined as a dictionary. And if I'm checking the type of B, I see that it's now considered a dictionary. We talked about isInstance before too. So if I was running isInstance and I would say B and dictionary, I should get the value true. All right. The last way, another, I'll say, final way that we can use DICT function in order to create dictionary is a specific use case, but it's when we have a zip object. Zip object is an example of the case where, let me just add some information here. So zip is a type of an object which is an iterator of tuple files where the first item in each past iterator is paired together with the second item. This is an example imagine we have two lists, two tuples. So I have John, Charles, and Mike in one list. Let's say we want to pair these people with people in the second. So the way zip work is, it's going to, so if I'm zipping A and B, it will pair up the first value of the first tuple with the first value of the second tuple. Let's say we want to form teams. So if I am forming, you see that the type of this is going to be, it says a zip file. If I want to print this file, I need to, what I can do is that I can assign this into a variable y, and to print it, you have to convert this into a tuple. So I can say print tuple y, and we see that now we have all the values extracted. So every first value with the first value, and it will go as long as we can match. Let's say if we wanted to match all four characters, I can say match Jessica with Vicky. So we have that. And now if we have formed a zip file, the syntax for using dictionary is, a zip data object. We use dictionary in order to zip both files. So here I can say, give me a print of dictionary of zip of A and B file. All right, so if I'm printing this, now I see that now we have a dictionary where the keys are the first characters, are the first values, the values are coming from the first tuple. In addition, we have values that are coming from the second tuple considered paired up with the keys from the first tuple. So this is the second way. The third way that we can use dictionary. The last topic that I want to cover in this video is list. We know about list comprehension, but now let's talk about dictionary comprehension. Okay, so in list comprehension, we could write a for loop in order to populate our list. In a similar way, in dictionary comprehension, we can use a for loop in order to populate a pair of keys and values. The syntax for this is going to be key column value for key comma value in whatever iterable condition that we set. All right, so let's run a simple example. Imagine I have a dictionary where the values of A, B, C, D, and 1 and 2 are assigned to set dictionary tuple list, and 1 and 2 for Java and Fortran. I want to use these values and replicate. I'm just going to call, let's say, replicate dictionary is equal to, and here I can say, again, looking at the syntax, we can say we are using key values, right? So key value for, and then we have key comma value, and I can say iterate these from the input dictionary dot item. So this will basically go through each value from the list above, and it will iterate and it will populate into a replicate. Okay, so if I'm running this, we see that we have all the values in the same order, although the order doesn't matter in dictionaries, but we have replicated each of these values into a new list. Now here I could have said if key is, let's say, equal to A. So if I was doing that, keys in dictionary, I could have said only create a list when the key is equal to A, or when we could have said not in A. So if I'm doing that, it will skip that value and it will create anytime our item key is not equal to A, we will have the second list. So now let's see how we can solve the question we had in our previous class using list comprehension. So imagine we had the question where we wanted to write a program to swap keys and values. So if I want to now solve this, let me just say this was now here we could say swap names is equal to, and we could say a pair of values and keys for, instead of now v and k, I could say k and v in dt items. So it's very similar to previous example. The only thing we're changing is we're trying to reverse those values, right? So now if I'm printing swap names, I should be able to get a list where the values are reversed. Again, very similar. I just using this format so the code is a little more clear, and we'll see that our values are now reversed in this list, in this dictionary. All right, so if you have figured these out, I want you to think about a question where, imagine we want to write a dictionary and we want to write a Python program that goes through the grades that exist within a list. Imagine we have a list of students: Alice, Bob, Charlie, and David. And we want to write a code, let's say actually write a function. So let's write a function that goes through the grade and returns the student with the highest grade. So I want you to think about this, and we will discuss the answer to this question later on.